is up? 1 hour and 22 late this time, compared to what, 10 minutes last time. Not to be, well, I'm going to try my best to get on top of my schedule. It was, you know, the usual not getting to sleep until like a couple of hours after I wanted to, and yeah, all that jazz. Where's good for the webcam? Yeah, I think this is good. Okay, so today it's quite hot. I think it's 27 degrees. It's going to be outside. I have the window fully open, but like the air that's coming in from the window is just hella warm. The laptop is struggling, right? It's like, whoops. Been at sort of 80-85 degrees for a while now, and everything else is, I think, ready to go. I'm not gonna do another final synchronization test. If you look at the third screen, the hand and the cursor are moving at about the same time, so it's all good. Feed, microphone, camera, screen capture, action. And I actually do have, you can't see it now, but I managed to open a Twitch chat client that I have it hidden behind the webcam, where the webcam feed is showing. I can just about see it there. So I've just sort of tucked it away there so that I can keep an eye on chat if there is any. If not, it's just going to look like stream chat, empty, fine. Laptop is properly taking off now. Fan is just on high, like fantastic. Whoops. And yeah, so this is the 1 to 3 p.m. session Sunday. See if we can get it done by 3:30, and next one's going to be 9 to 11 p.m. also today. All good. So yeah, all good. So today, yeah, we're gonna look at the first task, literally the first part of the first task, MapReduce part 1, and yeah, having looked at, sort of revisited last week's stream, I'm gonna be a bit braver, a bit more forwards, try to sort of hack through the material a lot more quickly, just because, I mean, you know, sort of dancing around the problem and not getting engaged in it was a bit of a waste of time. I felt a bit too much just rambling last time, so I'm going to try to be a bit more focused. I'm going to try to be a bit less stressed as well. Had a bit of hiccupy breathing, but we'll see how it goes. Mum's just come back. Wait for her to get out of the way, and in the meantime I'll just dig up everything that I need. Ah, fuck, I actually closed the, what do I want? Firefox. Yeah, I lost the bookmark bar. Lovely snap there, thank you Windows. Oh yeah, this I have open, maximized, don't I? Yeah, there we go. This file here got made by the test, didn't it? This didn't used to be there. I don't know what exactly I'm looking at here. It's just all the numbers starting from 0 to like 100. Yeah, 99999. 100,000 minus 1. Don't know what that is. We'll find out. Getting a bit self-conscious. Let me see if I can get rid of my mum. Sorry about that. Yeah, camera's all good. Okay. I mean, without further ado, I'm just gonna literally start hacking my way through all of this. No need for too much lengthy chat. So I mean, I made a sort of quick. This is just yesterday's demonstration, the little thing that we wrote out. But this, right? very brief summary from last time. These two functions that I'm supposed to write, right? I'm supposed to actually implement these. Do map and do reduce. Divides up output of map task, gathers inputs for a reduce task. So like, I mean, I'm still bare confused about how all of it works in total. Like, the general outline of everything, but whatever, I'm gonna go for it. Starting with do map, I guess, because that is the first thing that's written down there. Cool. The whole getting familiar with the source thing, don't really know how much I should get familiar with the source, if you see what I mean. I tried to sort of speak my way through this, and so yesterday, right? And so I'm just gonna hope some of it stuck. Like, okay, we'll see how it goes. Maybe it's hay fever. Like if I have the window open, but I'm not gonna worry about that. What I will do though is if I blow my nose, I will actually mute the microphone. I feel like that'll make for a slightly easier on the ears experience this time around. Have a nice sort of mute hotkey set up. Okay, so let me just put this up in the corner. Let me just skim this again, just as a quick introduction to get the mind thinking about it. You know, we'll be calling, distributed and sequential. Those are the entry points for the application, I guess. I mean, we're not editing those, we don't know how they work, but you know, number of input files, a map function, a reduce function, those are all cool. We spoke about those at length. They're going to be not even implemented yet. Part one is, I don't know, there isn't even a map or a reduce function yet. Those are going to come from the word count example. Number of reduced tasks. So that's the, splitting things up. We get to specify the level of reduced tasks. Yeah, then the master does stuff. We don't actually care about that yet. We can come back to that. How the RPC server works. We can forget that now. Each input file is one map task. Okay. Yeah, I should write that down. That's important. Control FN and file is one map task. It considers, do map called at least once. I don't know why at least once. I mean, I prefer it to be literally once, but okay. At least once per map task. Shall I? Do you know what I'm going to do? Word wrap and just line break. Oh, actually, line break the classic indentation way. I think that works fine. Okay. It either does so directly with sequential. We only care about sequential for the time being. Reads the appropriate file. So yeah, do map reads the file, calls the map function. So this brief sort of breakdown of do map. Laptop is so toasty. It's bunning. Reads. I'm gonna put its input file because I'm gonna for the time being. I believe there's a each file corresponds to one do map, right? Instance. So do map is per input file. I'm hoping that works out that way. Cool. Yeah, reads its input file, calls map function on its contents. Writes results key value. Yeah, I'll just write down dict format for dictionary. Writes results to intermediate files. All nReduce of them. nReduce the custom parameter of reduce tasks. Hashes each key to pick reduce task to assign to. Right? So toasty. Hope the laptop sort of survives. It's not gonna like heavily throttle. It's running at basically full speed most of the time. 3.3 GB. It's not right. These are megahertz, so gigahertz. You divide that by hertz. Yeah, you just divide that by 1,000, so it's 3.3 gigahertz. It's really taking off now. Fuck. Has Windows Update started again? Sorry about this. I knew it. I fucking knew it. RIP. Windows Update. My sweet prince. Yeah, I'm gonna have to go through the services manager and just turn this off, like turn Windows Update fully off. It's really difficult to do that on Windows 10 compared to previous versions, but fuck it, it can be done. Just need the laptop to chill out while I'm using it. Very, very basic usage case. I'm doing something complicated, therefore Windows Update should not be running. But yeah, you tell that to Microsoft. You tell that to any like massive company that makes software, it's just fucked. They don't know what they're doing. Don't really want to work for a company like that. Yeah. So, okay, so now that I'm reading this again, I'm thinking, okay, so lots of results of the map tasks, which I guess each result of the map task comes from a single piece of data the map function is applied to, but those get batched into map tasks which contain lots of these pieces of data, and so do map is going to split the map task, the results of that up, and assign them to different intermediate files by hashing the keys. And each key obviously picks out an individual piece of data and an individual piece of result that from the map task, or the map function, however you want to look at that. So the point is, yeah, that would explain why there are nmap times nreduce files, right? The point being, it's sort of, I mean, what was bundled into an nmap task can end up in a different nreduce task, or what? Just ignore that I said n there. I don't know why I said that, but yeah, I mean, that works out. And so the intermediate files. Well, I mean, the intermediate files correspond to both map and reduce tasks, and you can see that from the 0 and 1 for the map task, 0, 1, 2 for the reduce task here. That's fine. And there's a prefix which is God knows what. Well, let's have a look. I mean, it says XXX here. This is not an intermediate file, it doesn't have the right format. Okay, never mind. Prefix map task reduce task. If there are 2 map tasks and 3 reduce tasks, we get this example. And so yeah, we use local file system, but like every worker must be able to read files written by any other worker. Every other worker, as well as the input files, and so real versions use distributed storage systems. Okay, let's also quickly summarize do reduce the same way. Tinny trap beat playing outside. Bees in the trap. Literally just coming out of somebody's like Sony Walkman phone or something. It sounds absolutely awful. Alright, next calls do reduce at least once. I'll write that down here. Do reduce called at least once. Per reduce task, yeah. As with do map, it does so either directly or through a worker. Do reduce for reduce task are traps coming out again. Yep, do reduce collects its intermediate files. in fact, this is really one step in. You know, if I could literally just put that there, get rid of this. But yeah, from each map task calls a reduce function for each key that appears in those files. Produces MapReduce results files. Then merge called so it says that, yeah, merge is stored in this file, which we don't really care about, to merge and reduce result files, or and reduce result files into single output, and then it does a shutdown. That's not it, but it's shut down. Let's go, part 1. This is it. Let's see. How are we doing for time? Stream time's 20 minutes so far. It's fine. Not too bad. Yeah, come a little bit close. No, this has to come down, doesn't it? Well, I don't want it to, I don't want it to be too low, because that's a slightly dodgy angle, but yeah, this is fine. Also, don't want to grumble too much, like, speed like this, because I just fucking woke up, didn't I? Woke up at like, when did I get out of bed? It was like 12:20 or something. I mean, I predicted in advance I would not be able to make 12 PM start, but alas, mate, what are you gonna do? Yeah, so we need to fix the sequential implementation, the basic version, the simple version, missing, you know, the function that divides up the output of a map task and gathers inputs for a reduce task, and those are do map and do reduce, which we are going to write, and so we're going to have to read all those comments. And this is the test suite, this is how we run the test suite, blah, verbose output, and that's literally it. So it literally just says like this. That's all we care about today. Well, this session anyway, maybe next session, depending on how fast everything happens. Yeah, so, I mean, you know, divides up the output of a map task. I'm just going to put that in brackets down here under, you know, put it under the, you know, rest of the stuff I've written down about the relevant function as a kind of, this is what it's supposed to be doing, generally speaking. And yeah, sequential first for simplicity. Sequential, don't forget, is the version that doesn't actually run anything distributedly, but instead like just runs it normally, so that we can make sure we've implemented these things correctly, do map and do reduce, and everything runs as if on one computer, but then we will try to generalize. Step 1 though, implement the easy version, the sequential version. So let's go. No more of that stuff is necessary. Boido. Let us begin. Yeah. Do map and do reduce. Where are they? They are in common map and common reduce. In fact, they are basically the entire function. So the entire file is common map and common reduce. So as you can see, the file literally only contains do map and do reduce respectively, except for this file containing the hash function. So the hash function we spoke about takes a string and returns an integer. The string is the key that gets changed into an integer using some algorithm that we don't really care about what it does. It's a hashing algorithm. If we want, we can test it out. Don't know how to prototype stuff in Go. There's not really a REPL, like a read, evaluate, print loop. Doesn't really. Don't know if that exists. But like, yeah, because this doesn't have a main. It just says package MapReduce, but it doesn't have a main file. Does this say main? Does anything say main? Is there a main anywhere? Master is probably not main. If there were a main, where would I put it? Common? No. Common, it should be a module, shouldn't really be main at all. But what did we say about this when we were reading how to do the testing, for example? Test is main, isn't it? No. Control Shift F, find in files. Is this find in files? I don't know. Main. Oh yeah, there's an src main that does something. It has a bunch of these functions. So I guess yeah, MapReduce is being used as a kind of I kind of wish. This is an interesting question. I don't know how to prototype stuff outside of their explicit testing framework. Like, how do I test stuff for myself? Answer is you probably don't. Something like this I could probably use online. The online tour of Go thing, where I import the hash, or I could just get on with it and not Java State vibes. Yeah, what was I saying? Yeah, with this kind of thing, I guess I could just not waste time and just get on with it, assume it does what I want it to. Like, I'd like to, just for demonstration's sake, sort of show how a hash works. I'm going to spend 1 minute trying to do that. If it doesn't work out, that's fine. If I just jump into a tour of Go and get the sandbox out, write this thing, so then I can import hash slash what yeah, FNV. I guess FNV is the type of hash. I don't actually know what it does, but for example, yeah, I can see if I have this, I can just type in print iHash. Why is it called iHash? I don't know. Let's hash like the empty string, for example. You should get something totally random, nice random number. But the point is, if I type in like bird and hash that, I get like some random number. Yeah, put bird in a strange location there. That should be going here. So yeah, so what is it? 39329195 and if instead of that I hash burb 2926, yeah, there's been a change of things, right? A big change. That's really the point of a hash that I was trying to get across. It's very sensitive to the input, and so even if there's a lot of structure in the original dictionary, doing the hashing, if there's a lot of correlation between the keys, the hashing is going to send them to various numbers, which means that if we consider these numbers as approximately specifying which reduce task somehow, say we take the numbers probably modulo the number of reduced tasks, so we just look at the remainder when we divide by the number of reduced tasks. That will give you, some random numbers. Unpredictable. I know random isn't the right word for that, because it's always the same. It's deterministic, but unpredictable numbers. And that gives us our load balancing equipartition and tip. Okay, cool. So without further ado, that's the hash function. I have to read all this shit now. Best not put it off, I guess. This is DoMap. Okay. Let me actually, hang on, I am going to, after all, blow my nose. So what did I say I would do? I said I'd just mute the microphone. Yeah, well, hopefully that works out. But anyway, what was I talking about? Microphone, camera, yeah. Still quite new to streaming, so bear with me with my kind of struggles to figure out what I am doing with what. Okay. Oops, so I meant to tab into my text file here. So DoMap and DoReduce, right? Them ones. This is, I mean, we have a call signature which tells us vaguely what the function does. I mean, it tells us what we put into the function, and so the function's behavior should differ depending on what what arguments it gets passed. This isn't necessarily a pure function, but nonetheless it gives us an idea of what it is. Job name, the name of the MapReduce job. Don't know why the jobs have names as such. I guess the scheduler, the server, they handle that. I don't know. Map task. Which map task this is an integer. Yeah, I guess that's just 0, 1, 2. Well, as in the things that get assigned to the intermediate file names. So this is why I don't really know what job name is as such. We will find out later. In file is a string that does something. N reduces the number of reduced tasks that we're gonna send out, which is R in the paper. Oh yeah, I still haven't read the paper, have I? That's fine. I have some time today if I decide I need to read the paper. Mapf is a function. We pass in a... Oh yeah, mapf is going to be the pure function. So this is what I meant about passing functions around. The pure function the little function thing that we can just write down somewhere and then pass it as an input to this function, and it's a pure function, so it will, it'll always do the same thing to whatever we apply it to, and that's what makes it useful to pass around. So that's what a mapf is, and it's it's going to be a function that takes the name of the file and its contents, and it returns a list of key values. What in the fuck is a key value? Well, key value pair, right? It's a list of key value pairs, so it's like a dictionary, but I mean, is key value a thing in Go? Type key, I don't know where. Shout out to Visual Studio Code showing me stuff. It's a struct that has a string, a key string, and a value string. So I mean that is a dictionary, I think. An array of those is a dictionary. Slightly simpler than a dictionary because a key value. Dictionaries have within them all the baggage of how they're managed, like when our file's deleted, when is more memory allocated. This is, because it's working with a list, I guess it's slightly easier to understand if you wanted to think about it, but we don't need to think about that, I don't think. So from the perspective of sorry, I just lost my train of thought slightly. Yeah, from the perspective of the programmer's experience, they are the same thing for now. We'll find out later. So let's read this. Do map manages one map task. Yeah, this is what we said. It should read one of the input files. So yeah, do map goes for one input file. I guess in file is the input file. I don't know why they didn't just call it input file. But yeah, we pass in the input file into that argument. Calls the user-defined map function mapf for that file's contents, partitions mapf's output into MapReduce intermediate files. It's one intermediate file per reduce task. The file name includes both the map task number and the reduce task number. Use the file name generated by reduce name. So you can see it's really spoon feeds you. You even have the name of the reduce. We have the reduce name function that will give us the file names just by typing in the job name and the map task. Well, map task is manually 012 whatever. R is manual reduce file. This is obviously going to be when we write it down. Shall I just do that now actually? Make my own user-defined comment at the top, and I'm going to say, so this shit, right, reduce, the way this is going to be run is probably verbatim. Job name comes from what we send into do map, so the reduce name will depend on job name, which is passed into the original function. Likewise, map task also passed into the original function, and R is going to be the reduce task, and we choose that by using the hash function, if we recall how that works. And the hash function is going to be applied to whoops, just paused there for 8 seconds. On previous versions of Windows, you will remember if you did that by accident, held the filter key shortcut, it would break the keyboard. Like it would set something to something incorrect, and then whenever you used the keyboard or mouse, shift would always be activated or something. It would just mess with man's head. Yeah, okay. This is not what I think when we are generating, see it says the intermediate file for reduce task R, so when we actually generate the files, we are just going to for loop this to like 0 to MapReduce -1, like those things. This isn't actual code, I'm just specifying things in outline. And then which file do you write to? Well, that file will be reduced named this shit. Let's just copy it out. again, where it's determined the file that we write to is going to be I hash key, whatever the key is. This is all thinking in advance. It'll make more sense when I get around to writing it down. This is just because it mentioned reduced name early on, so I thought, yeah, why not do a bit of work on that. Like to create int files. So this is intermediate. To assign keys to files, also intermediate, but I wanted it to be lined up and nice and flush. Cool. Call iHash, see below on each key. iHash key. This is what I mean by spoon feeding. Mod MapReduce, yeah, okay, fine. This is what we said, didn't we? When I was talking about, how you can get the key to choose a file, because the key is some random number, a big number. Sorry, the hash. What the hash outputs is some unpredictable big number. But we need to just choose between MapReduce files, so we just modulo MapReduce, which gives us, what this is in maths and in programming is the remainder when we divide by MapReduce, and so that's a number between 0 and MapReduce minus 1 inclusive, and therefore it specifies a file, right? See how that corresponds? And that's how we pick R, so these two are R, for a key value pair. Mapf is the map function provided by the application. The first argument should be the input file name, though the map function typically ignores it. That's interesting. Well, yeah, it shouldn't depend on the input file, should it? Don't know why that is the first argument. Second argument is the entire contents of the input file, which is obviously more important. Mapf returns a slice, which is a list in Go. It's called a slice, containing the key value pairs. Mapf returns a slice containing the key value pairs for reduce. See common.go for the definition of key value. Okay, so this is where key value is defined. Yeah, we just hovered our mouse over it, but I mean, it's the type used to hold the key value pairs passed to the map and reduce functions. Fine. Feels totally redundant. Why not dictionary? But there's probably a reason that we will find shortly. Where were we? Common map. Look at Go's IO, util, and OS packages for functions to read and write files. In JavaScript, that's handled by FS, or in Node, not in actual. Original JavaScript doesn't have FS, I don't think. Maybe it does. I don't think it does. FS stands for file system, which is sort of like IO, which is input output, utilities, OS. Don't know why I would need OS. Well, I guess, I don't know. Why you need both is... never mind. Coming up with a scheme for how to format the key value pairs on disk can be tricky. Use the colon, surely. Especially when taking into account that both keys and values could contain new lines, quotes, and any other character you can think of. I mean, I was going to say use JSON. One format often used for serializing data to a byte stream that the other end can correctly reconstruct as JSON. You are not required to use it, but as the output of the reduced tasks must be JSON. Cool, yeah, I'm just going to use JSON then. You can write out a data structure as a JSON string to a file using the command code below. The corresponding decoding functions can be found in common reduce Go. So this is the encoder. Remember to close the file after you have written all the values. Closing files. Facts of life, you have to close the file when you're done with it. Comes naturally. If you're using Windows, you just click X. You know, it's like, oh, I'm finished, I'm just going to close the program, the entire program. But when it comes to programming, yeah, if you don't do that, you can easily forget, because you can't see it. You could just forget to close it, and then you have something like a memory leak. It's just taking up memory. If you keep opening files without closing them, it's the equivalent of that, you know. It's like how the operating system will slow down if you do that. Well, indeed it will. Same thing happens with the program if you don't close the file. Yeah, tutorial of Go tells me I should defer closing a file. What defer does is it runs a function at the end of another function. When the function returns, after that, defer happens. So I'll use that. More on that when we get to it. And a quick note to say what JSON is. Web programmers will know, even people who are not web programmers will know about JSON, because like it's just used to store data that web programs can understand. And so if you have like the Pokemon Go map requiring a JSON dictionary that for every Pokedex number assigns a picture in order to get the icons on the map, that's what JSON is for. Among other things, you can use JSON to, well, any, you know, if you query like any web service, for example, I have found some web services that encode points in the real world into postcodes. Well, the data you get back will be JSON, a JSON dictionary, always is. And there's a completely standard way of, well, converting arbitrary data into a structured format using JSON. So you have, you know, it says here, formatting the key value pairs, which are strings that can contain new lines, quotes, anything else. Well, JSON can handle that. And the way it does it is it uses quotes. Everything between the quotes is fine. So obviously if you have another quote, that will screw it up. But if you just write a backslash before the quote, then the quote gets treated as a like literal quote rather than the instruction to start or stop reading the string, the text. So yeah, in JSON you can have like you know, some words, whatever, letters, and then you have like a quote. You have to write it like this. Yeah, sorry about the autocomplete there. So then this quote gets interpreted as if it's part of the text. So like what this actually means is that. But if I did this, it would actually mean this. And this would throw a syntax error because it doesn't mean anything within the JSON format. There are some other characters that have to be escaped, so that's called escaping the character. But I don't remember what they are exactly. I think something backslash, because I think backslash can be used to signify a lot of things. If you want to type a literal backslash, you would do a double backslash, which makes perfect sense, obviously. Any number of backslashes you need to do, just do any number of double backslashes. Obviously you can write whatever text you want by doing that. So that's the basic idea of JSON. We don't actually care about how the JSON works, because we're going to run these functions and it will just give us what we want. We don't care about, you know, implementing the actual function that converts our keys and values and whatever else needs converting into JSON, because this is already there. It's in MapReduce, a common map. Is it in common reduce? I didn't see it in common reduce when I flicked through this function. It didn't seem to be there. Did I delete something by accident? Maybe it's not common reduce, maybe it's just common. I do not know, that's a bit strange, isn't it? When it says like yeah, this is, I swear this is just not true, because there's nothing in common reduce except do reduce. Unless they put it in the comments. Which they haven't done. Okay, so forget that. JSON is a small detail in the grand scheme of things, we'll look at it later. Your code here, part 1. Okay, nothing hard about this, in my opinion. Ah, sorry, I forgot to mute. God, there's a bunch of crap from when it rained on the windowsill. I should really deal with all of that, shouldn't I? Deal with things and shit, yeah. Sort your life out. Sort out your life, you can't be my wife. Sorry, that was totally without context. I started in the wrong place, so I can't be bothered to provide the context now. Yep, so should get on with it then, I guess. Let me just see how we're doing for time. Well, we started at like 20 past. So actually it's almost been an hour, hasn't it, already? Yeah, I still feel like I'm being quite sluggish. Still not actually done anything, but we can do it now, I guess. I'm gonna type the function up here. So, brief overview of what this shit does. Reads the input file, calls mapfn on its contents, writes the results. We have an example of an input file. We should find one of those. Here, I think. Being Ernest, Dorian Gray, Frankenstein, yeah. Let's have a look. So this is the input file. This is the input file in the so let me just open it within the view of visible spectrum. This is the input file for the word count example, but it's another, it's an input file in terms of the map task, I guess. Is this the input file, the type of input file that goes straight into the map task? I'm not entirely sure. It's not totally clear at the moment if that is read or if it reads some other file. So yeah, the input file. Let's see if we can find a bit more information about this. What the input file is. I'm gonna leave that up just if I want to test some Go. Yeah, it provides a number of input files, and domap reads the input file directly, doesn't it? The master considers each input file to be one map task, so it doesn't itself do anything with the input file, it just passes it to domap. It calls domap at least once, at least once for each. So once for each is now once. At least once for each map task. And spits out key value pairs. Yeah, I think the input files are passed verbatim to the domap. Either way, let's assume that's the case for now. it reads it, calls the user-defined map function, which is passed as an argument here for that file's contents. Partition mapf's output into MapReduce intermediate files. Can we just run mapf on something to test it? I swear I can do that by doing this. If I type func main, this is like the main function for this thing, and so if I decided to test common map out, I think it would run this. Let's find out if that actually works. So I'm going to import fmt to make life easier. Fmt is the function that is used, the module that provides our method to print lines, print text to the console. The console is down here. I can press Control Prime in order to turn it on. Not PowerShell necessarily, but like output. So let's do a quick. Let's see if this works. So I want to run this within Visual Studio Code. Debug, start debugging. The thing is, I don't know if this will automatically do what I want it to do. Cannot debug non-main package. Nightmare. This is what I mean. Like, I don't know how to use Go to debug individual files. I don't know what the main package is at the moment. It is bare annoying, to be honest, that I can't do that. I can do that in any other language, no problem. Python and JavaScript, I wouldn't know how to do that. So I want to find out if I can debug from within here. Can I swear if I just comment this shit out and write down package main, that might do it. Like, let's find out. Found packages MapReduce and main in. See, I'd have to fuck up the folder structure in order to do what I want it to do. So I might do a bit of reading, perhaps after the stream is gone. Just do a quick read to see if I can find out how to debug Go just from within the actual file. How to do like really simple debugging. It would be great if I could do that without running the test. Maybe if I run the test, I can run tests here if I want to. I can even pick bash. Can I pick bash? No, I can't. Bash is not there for some reason, but it doesn't matter. But the tester is this. So I have to run the preamble. Sorry, ran the wrong preamble. Yeah, I'm gonna have to do this every day. It's quite annoying, but it's fine. I can handle it. Just copying all of these. Maybe I should just write a shell script. Oh, export is not. Can I not have bash within VS Code? I probably can, but I don't know how. So instead, I am just going to run git bash in in this folder, which is the root folder of the whole project. Where is the thing? I lost the thing. See, it has not, it hasn't even printed what I wanted it to print, which is, yeah, annoying, I guess. Maybe there's a different file from within which I can test, but as it is, I mean, yeah, this is interesting. I didn't really foresee this as being a problem, but I really do need somewhere where I can just test stuff, and I'd like to be able to test, to experiment within this project. And I don't know what the best way is of doing that. So I don't know if maybe I should just spend the time trying to figure that out now, or if I should try to write down some code that I can just guess works. I'm gonna go with the second one just for the sake of the live stream. I want it to be a bit more involved, do some actual work. So I'm gonna just guess the answer and not test it yet. For now. We'll see what happens, and we'll see if we can test. We can test, obviously, using MIT's tester, this thing. But that's absolutely, don't know if that's going to provide enough information, but let's find out. So let's get to work. So what I really wanted to do, if I could, is it would help me write the code if I could find out what map does if I just apply it to but I don't even have a map F that is, okay, sorry about this rambly complaining that I'm doing at the moment. I'm just annoyed about how this is all put together. I am just going to guess the answer, legit, I'm just going to guess the answer. Let's go. So yeah, we need to read the input file and call mapfn on the contents. That is literally what it says here. Right, this is the basic idea of what this thing does. Let's try to, I'm going to write my own comments where I just sketch what we're doing. So task number 1, read input file, which is in fact called infile, according to the call signature up here. Call mapf, which is the user-defined map, on contents of infile. And then mapf returns a list, a dictionary type thing, a list of key values, which are going to get partitions. Split result of mapf according to hashes of keys, and it splits it, and then the question is, how does it save it? That's the last thing we care about before we've done our sketching. Both the map, there's one intermediate file per reduce task. Both the map task number and the reduce number. So reduce name is going to pick the file. Yeah. So what we should totally do is well, we can do it in any order, I guess, but for me it instinctively feels better to do it here. What I'm going to do is create the intermediate files. Like I said, by running this. And then the last thing we do here, we've split it according to hashes of keys. What we're really doing is assigning each key value pair that results from this according to the hashes of the keys, we are assigning it to the intermediate files. How? These are implementation details of mapf. That's not relevant to this particular bit. You know, how do you format the key value pairs? The answer is we serialize them into JSON. Right, so a key value pair gets encoded. Well, it literally says what to do here. So the key value pair, they get iterated. You know, the ... here is going to be the output of the map task. What it will do God, the way that code is written is still so dodgy in my opinion. What this is saying, this line here, we run the encode of the key value pair. For each key value pair we encode it. And what encode does is it runs an encoder, and in here we pass the file. But the result of that is assigned to an error variable, just in case there is an error. The point is, if this returns null, it will the error will be null, and therefore it succeeded. That's how that's supposed to be interpreted. So I'm not going to bother explaining those details. These are like really classic programming idioms, which are kind of feel extremely out of date to me. But I'm just gonna roll with them. Yeah, legit. It tells you what to do. So and write result to corresponding intermediate file. And you know, I'm just gonna literally split. It says remember to close the file after you've written all the values. Close all files. Yeah. So these are the things we're thinking about with this particular function. So create intermediate files should be pretty easy to do, because we're just making some files. These are the names of the files. This shit from 0 to MapReduce -1. So I'm just gonna write that down once I have looked up how to create files in the first place. So empty files. So we start off just by writing the empty files, and later on we're going to put stuff in those files. Read in file to do. Learn to read file. Yeah. Call mapf on the contents of in file should really be self-explanatory. I don't know. Split results of mapf according to hashes of keys. Do that to it. You know, apply to each one. Write result to corresponding intermediate file. This is where I'm gonna paste in the JSON encoder code. Oops, copy it. Actually, I don't want to edit the comments in case I fuck something up. I saved it and it deleted like a bunch of spaces or something. Close all files. Yeah, every time I save it, it gets linted. I think that's what linting is. It just gets like tidied up. So if I have like lines of comments with nothing written on them, if I save, nothing happens. What the fuck? I do not know. It does not matter. Minor tin. Okay. So IO, util, and OS are the packages we're going to have to learn to use. in order to read and write files. These are I should point out in case I haven't. These are all comments. They're not run. They're just for me to sketch what I'm doing before I actually do it. That's it. So let's just jump on and do all this shit. These are 6 steps that need to be done. So close all files. I'm gonna move that up here. Well, I mean, we're reading one file, the input file for this MapReduce task, for this map task. Sorry. We read one file, and we create a bunch of empty files, and then we append to those files, which means we are going to be opening those files for editing. So I'm just going to split this up as a task to do here and also here. This is not actual code, but like, yeah, this is actual code. These 3 lines of code, this is just my comment. Close all files. So I have assigned these 2 to the correct place, I don't need them anymore. And that's it. Okay, so it's time to learn how to open and close files. Yep, should be fairly basic. Let's just read how to do it. Let's start by just creating empty files. Are these? Yeah, they are text files. Erase, meaning that you don't know in which order things will happen, and you could have unexpected effects, side effects. So the existence check happening at the same time as the file being written means that if the file gets written before existence, you get a yes to existence. If it gets written after, you get a no, and you have no way of knowing which will happen in which order. That's what erase is. Good example of erase. Erase condition, I think, is a full name for that. You can open the file with this. So okay, OS. Yeah, I guess I should just quickly import these 2 things. You know, import OS and import IOUtil, which is apparently should be written like that. I don't know. So I just saved and it got deleted. Why, I do not know. Allow me. I think it's deleting shit that's not being used. Why? That's not that. I can kind of get why it's doing that, but that should be like a final cleanup, not an intermediate linting. Nightmare. Fly. Fly just keeps coming back. I'm going to see if I can get out of the window. Yeah, it's gone. Went out the window. You can open the file with this to create it if it doesn't. This isn't really the problem that I'm looking at. I literally just want to create the file. You know, working with files in Go, click on this shit. Import, yeah, var new file and error. Don't need to write it that way. Okay, this is what we want to do. I'm gonna not bother logging errors. at all. If error not equal to nil, log the error. I'm gonna see if I can go without that, if that automatically gets done somehow by the Go thing, the Go runtime. But if needs be, let's just make a mental note. I can write if error not equal to nil. Fine. This meaning not equal to. If error is, so if there is an error, if error is not nil. Nil being what is assigned by this, what this returns if there is not an error. Yeah, so literally just this. Let's just do this. I'm just going to copy this code block in wholesale. So yeah, task number 1, create intermediate files. This is the code that creates the files. Like I said, I'm going to go without the error logging. Print line prints the new file, closes the new file. Right, so and that's it. That's all we care about. os.create, and this is the name of the file. So the name of the file is going to be this. To make it just easier to read, I'm going to go file name. Right. File name. I'll just quickly define as this thing. And what this will be is I, and all of this is getting enclosed in a for loop. We iterate over range how does one range over numbers? I cannot remember. Let me just write the full code block down. So basically what I'm trying to do with this is just iterate over all the numbers from 0 to MapReduce -1. And for each one of those numbers I'm creating a new file with that name. Well, the name is given by reduce name, which takes job name and map task from the original function input, and I, which is the counter that measures which of these tasks were on 0, 1, 2 up to MapReduce -1. So the ith one. And that's what it does, right? This is just the name of the file is determined by this function, and then new file gets created using that file name. I don't know which directory this is supposed to go in. Hopefully it will just put it in like the root directory. I don't think that's supposed to be there, but never mind. The files can get deleted later on if they're not supposed to be there. It creates the file, logs the file, prints the file. I don't want to be using log because I'm not using log, I'm using fmt. And then the file gets closed down at the end. So I just want to remember how to do the whole, how to do a for loop over the first n numbers from 0 to n -1 inclusive. And I can definitely find that just by going here and tapping through it until I find where range is. Not here. No, it should be there. It should be there, so I just skipped it by accident. Where did I learn how to do a range? Google. So I'm in range. You can use range to iterate over a data structure. Or can you not use range to iterate over? Go for loop n times. Yeah, this guy, this is straight up what I think as well. This is I mean I know I can do it this way, but that is, you know, an outdated way of writing a for loop. Years and years of C or Java indoctrination. And this has more upvotes than simple obvious, because this is, yeah, not more simple than this. This is an easier way of writing stuff. I mean, I started programming from Python, so that's why it looks easier to me to do that. But I want to find out if there's if somebody has actually, if there actually is an easier way, rather than iter. You can use iter. Which is a custom package written by some guy. Not happy about that. Who the hell is Brad? Yeah, fucking what? Yeah. I'm literally, yeah, this is such a minor thing. I'm trying to make a decision on which way I prefer of doing the simplest for loop. So I can use the traditional way, or I like this. Where the hell is it? I lost it. This. So just make an array and iterate over it. That's you know, it's I think that's just as nice as doing the counter. Wow, it takes up a bit more memory, but it's such a minor thing. I might switch. I mean, I can always just use the traditional for loop if I want to, the traditional one being this one. But for now, I'm going to use the slightly nicer looking one, in my opinion, which is that. So, you know, I'm writing MapReduce here as the length of the iteration. But the actual the indices go from 0 to MapReduce minus 1, which is MapReduce numbers. Because things start at 0 in programming usually. Okay? That should work. I'm not sure what the scoping is like for these, but hopefully every time the for loop runs, redefining one of these is going to work. If it doesn't, I will need to just instantiate outside of the for loop. See, this is in JavaScript. This would probably work. I'm not sure if it will work in Go. In JavaScript, it will definitely work because let is block scoped, so it always, each iteration gives you a completely new variable. even if you redefine the variable, that's fine. Here I think it might be necessary to define the variable outside the for loop. Details. And nobody got time for that. So this probably works. It might not work actually, but there's a good, actually, yeah, it's 50-50 whether or not it works, but the point is, without being able to test it, I think, defer testing until the end. Which is not what you should do if you're programming, but I do not know how to use Go. Yeah, learn to read the file, so we need to do that as well. If there is an error, panic, whatever. The most basic file reading is slurping a file's entire contents into memory. That is what I'm going to be doing. So that is done like this. Yeah, the whole byte stream method is like, yeah, basically when you're reading files, you can either load the entire file into memory straight off the bat, but if the file's massive, then literally you're using up RAM. Like if you're reading a massive file, all of that goes straight into the RAM before you do anything else with it. So what you can do instead is set up like a channel that passes bits of file at a time and then processes them and then disposes of them in memory, overwrites them with the next bit. There are kind of quite, fairly automatic ways of doing that in the real world, using like streams and whatever, like this kind of stuff, an array of bytes and loads 1 byte at a time. Not fussed. The files we're using are quite small, and to keep it basic for the first iteration of this task, we're just gonna load it all straight into memory. I love the word slurp. That's pretty much what's going on. Literally on the slurping. And so this is how we do it. We use ioutil read file. Start by opening a file to obtain an OS file value. Yeah, let's not do that. Let's just do this. What's our variable going to be called? Input file. Literally input. I think that works. We ioutil read file. Which file? Well, the file at the file name is going to be in file. Not going to bother with the error again. I mean, if I'm not bothering with because I don't want to comment out the error, because the idiom of Go is that that's where you put out the error, and if I delete it I might forget if I need the error where to put it. But at the same time I feel like I'm reading this and it kind of, I understand, the read file routines. The second output of those is going to be an error. Okay. Yeah. Fuck it. You know what? I'm gonna tag them. 2 is error. To be completely clear, return value. I think this is what it means. So this thing returns the new file object as well as the error. But if I just assign it to new file, then the error gets disposed of. I just have that feeling I'm going to need the error later on, so I'm just going to leave that there. Yeah, fmt prints, let's print then string version of the inputs. I don't know if, well, println, I don't think it even needs, I think it's polymorphic, I think it can print anything, it doesn't need a string conversion. But the thing is, if I change this, I cannot test it, so I'm not going to change it. So yeah, it reads the file, and let's close the file at the end. How does one do that? Let's just guess the answer. Defer in file, no, not in file, input. Isn't input the text though? Don't know, let's find out. 5 bytes, hello. So I'm trying to figure out how to print the actual value of what's in the file rather than just the file object. But I think DAT is the file, the value of the file, rather than the object. Not 100% that that's true, but I think it is. So DAT, I mean, this doesn't really demonstrate using it, but I think it's fine. Yeah, it's not the most useful tutorial. You just have to experiment, really. But yeah, this is okay. Defer input. How do you close the file, though? Just find a fucking better example. Fuck this. You know, if you run print file, it will actually print it. OS file is what OS open returns. Well, IOUtil is what I'm trying to use. Read file returns a slice of bytes. Oh, okay. Read file returns a slice of bytes. Input is a slice of bytes. Okay, but how do I close that? Do I need to close the file? I think IOUtil auto closes the file. I think let's read the documentation. I think it auto closes the file. Right, it returns, yeah, the array of bytes, which we can just convert into a string. Returns the contents. Does not treat an end of file as an error. And nobody seems to be closing the file, so I'm gonna not close the file. I don't think it needs to be closed. If we switch to kind of, you know, reading the file 1 byte at a time type thing, then it will need to be closed, but in this case it seems it does not. We can literally just do this, you know, do the string conversion right here, so that this is a string. And that's our input. And that's loaded in memory. That does not need to be explicitly disposed of. It's all good. It's all fine. This is hot. This laptop is like diabolical. But we are streaming, so call mapf on the contents of the file. Mapf returns the key value. Result is mapf called on, so result is going to be our key value array, list of key values. Mapf, we need to apply it to the file name. The signature of mapf, it says it down. Where is the signature of mapf again? I just read it, but I lost it. What does mapf look like? Oh yeah, it's up here. Mapf has to look like this. Specifies the exact signature of mapf. It takes file name and contents and returns a key value array. Key value is its own plural now. No. Results mapf. Alright, so file name is the name of the actual file, the input file, which is not important, but content is what's important for mapf. Yeah, it said down here, didn't it, that mapf, is the input file name, that's typically ignored, so it doesn't matter. Second argument should be the entire input file contents, which is input. That's what I'm calling input. Split result, which is now called result, according to the hashes of the keys. Easy peasy. We iterate over the result. So the result is already an array, so it's easy to iterate over. We just write that. This iterates over it, but we are going to be using... We don't care about the indices, but we do care about the values. All of the elements in result, those are V. Let's call them KV, the key values. KVs are, the key values, I'm calling them KV, and they are the results of this, and so that is a struct that looks like, let me just hover over it, this. It has, if I take dot key, I get the key. If I take dot value, I get the value. Cool. And what I'm doing for ranging over result is I'm taking the key, accessing the key, using that to determine which file it's going to by passing it, sending it straight into the hash. Taking it modulo MapReduce in order to specify where it's going, which reduce task. In fact, let's make the code a bit simpler. Reduce task ID is an integer. It is that integer, right? And this is the file that we are writing to. Well, the way I've written it now, see, I've basically just copied this here. I can just replace that with this. So reduce name, God, I don't want to save because it will get linted and that could fuck something up. Do you know what? I'm gonna be brave and save it, and it will get linted, and that will fuck something up. Why? Why is it? Oh, it's creating a single value context. That's a warning. That cannot be an error. If it is an error, okay, fine. I will define errors. Why? I can do that later. Blah blah blah. Reduce task file name is literally just this. And so then we use the encoder to send it into the correct file. I feel like we want an encoder to be present for every file automatically. So yeah, let's not close the new files up here. Let's close them later. Shall we define an encoder for each new file up here? Creates empty file. You know, these are the intermediate files we're going to be writing to. Here we create encoder for file. Right, and that will be this line. We need variables that will escape the block. So, what's the best way of defining these? Just checking, still the toasty 80%, still not throttling though, which is nice. Well, a little bit of throttling, but basically. What was I saying? I mean, I need the encoders to be just available outside of the scope of this block, and I'm not sure if that's actually going to happen the way I've written it. Well, obviously not, because I haven't actually assigned the values. Yeah, you wanna define an array of file names and an array of encoders. Technically, we don't need the file names; we just need the encoders. So let's just do that. How the hell do you define an array of new encoders? Do I have? I should. Sorry, I have. Yeah, I need JSON to be present in the packages. Encoding /JSON. Why not? Sounds about right. But now yeah, these fucking red lines are so annoying. Non-constant array. Bound MapReduce. Yeah, what? It's just not that helpful. If it actually works, I don't need to be warned about it until later when I can find out if it's bad practice or anything. So we should maybe just turn off the linter or something. So it's literally giving me warnings for stuff that I haven't even done myself. I guess problems are actual problems, not warnings. They will throw an error. I'm gonna try not to worry about it too much. Yeah, at some point I will have to deal with all of that, but yeah, I'm just gonna not worry for now. So when it says egg is, it's a new encoder. Okay, that has type star encoder from JSON. So can I just specify an array of I'm aware I shouldn't be referencing arrays directly so much. I should be using the slices, but I will change that later. I'm just for the time being trying to sort this out. It says the type is capital encoder. This looks like a syntax error to me. Okay, we have some actual errors here that we can actually correct. I see that now. Whoops. So let's have a look. So here we cannot refer to unexported name JSON dot. How do you? Okay, I'm gonna have to check this quickly. Yeah, I'm gonna have to check. Golang refer to type in package. This is basically what I want to do. Yeah. You import packages. That's what I've done. You get access to all of its exported identifiers. You can refer to them that way. Ah, yeah. Okay, the star goes before the pointer. Yeah, the star for the pointer first, and then the name of the type. That should work. Yeah, it's giving me non-constant array, but okay, let's Google this error to see exactly what it's on about. You cannot instantiate an array with the value calculated at runtime. Slice with the desired length. Oh dear. Yeah, well this is calculated at runtime in the sense that it's passed into the function here. But surely this is not a problem. Non-constant array bound. You cannot instantiate an array like that. But I mean, in this case I can replace it with a standard for loop here. The one we were talking about earlier, the old school type. But here, like, I really do just want an array of encoders. Instead, let us make a slice of encoders instead. Yeah. Fine. Let's do that. and sorry, and what? Oh, right. Yeah, no error. And here, yeah, okay, fine. It is just gonna have to be a standard for loop. Yeah, if it had been a fixed number, it wouldn't have been a problem, but. Ah, my bad, I have written these the wrong way around. Multiple value OS create in a single value context, so I think I literally have to do the error then. Yeah, I know, this is what I want to happen. To make sure the code is right, I'd like it to crash in the case without handling the error. Yawn. Yeah, it's not fun having to deal with details. I completely lose the motivation to even explain my way through them because they're just details, it doesn't matter. But I'll tell you what I'm going to do. I am going to try to just try to fix all of these errors. And then I'm going to call it a day. Well, a session for now. Move on with my life. It's been almost 2 hours, so it will be. I was kind of hoping I could get all of it out because it's quite easy, like so far. But having to handle errors and things, it's when you don't have the experience with the language, that it was always going to be like that, I guess. So no worries. Don't worry. Be happy. Gonna get lunch. I'm so fucking hungry. That's gonna help sort everything out. So no worries, no worries. Let's do it. Let's do it. So yeah, so it says that it's not possible to actually discard the error at all. So you need the error to go somewhere. What I'm gonna do is define a global arbitrary error and just assign shit to it, and then ignore it completely for now. The way I'm gonna do that is type var error. Right, that defines an error variable in the global context. It has nothing, but then I'm just going to continually assign to it. This does mean I'm going to have to, I think, I won't be able to define variables using the colon. Actually, I can do that. Hopefully it will mask them. As in, it will make a new error. Such technicalities, I don't even want to explain this stuff. Sorry. Ran my mouth for a bit there. Hopefully this is just not going to cause a problem. Yeah, it looks fine to me. So yeah, also this also has to be done here. So we're doing exactly the same thing, right? We are IO utiling read file, but the input is going to be the string of input. I mean, you know, they're forcing you to deal with errors. They're forcing you to do that. So it's a conscious design choice in the language, not a bad one. I think if I were making an actual program, I would find that very useful because I would have to deal with each error as it came up. But this, I feel like it's more of a test thing. Sorry, yeah. Reassignment here. What is the problem here? Cannot use string input as a type string as the type of the string has to be changed. You're not allowed to do that. Stupid shit. Input bytes. That should do it. So we have to have different variable names. We can't change the type of the variable. And this now requires a colon again. Colon defines a new variable. What is the problem here? New file is undefined. Yes, because I changed it to file. Cool, okay, I think that works. Go. Error declared and not used. Jesus fuck, seriously. Some of the others, okay, they're not used because I haven't written the full code yet, but like error not being used, I'm gonna ignore that. Deal with it another next sesh. Have I actually updated the sesh times? Yeah, I have. Next sesh is still 9 to 11. I'm quite happy to do that again. I will perhaps slow it down later, but for the time being, I want to keep up the pace. Particularly because this is not hard. It's just a bit of a grind because there are so many errors to deal with. Just jumping out left, right, and center. List to this. We have reduced task file name. We've defined the encoders. Oh no, we haven't yet, have we? I said okay. Encoder is that thing. For simplicity of code, I'm going to write it like this. Encoders I is json.newEncoder file. Right. That's all we need. That's all we care about. Done. Now then. That is us defining the new encoder. And so what we do now is we have the key for, stuff in KV. We are going to run the encode. Error is we try to take the encoder enc, which is actually encoders. Which encoder is it? Answer is it is the reduced task ID. That encoder is the one that we're going to be using. That's the file that we're writing to. I guess we don't even need this because the file name is bundled up into the encoder that we defined up here. You see the encoder comes from file and the file comes from the file name, so the information is there. We don't actually need this. That should really do it. So hopefully now the only error I have is error is not declared, which is absolutely fine. Just having to put error boilerplate. So yeah, we have written everything, we've written to the encoders, that's all fine, and at the end we just need to close all the damn files down. So let's defer a close here. That's a pointer to an OS file. We defer a close, so that when the entire function is done, it gets closed. Do you know, I think that's it. So I'm just going to dump all the errors using some boilerplate. Okay, what is our simplest method for discarding errors? Oh, I guess we can just run a panic if we want. That's not even a legit discard. Yep, this will be our boilerplate. Every time an error is defined, sorry, what's going on? Pasted that wrong. Every time an error is defined, we panic error. Whenever I fucking save this, it's just gonna explode this house again, isn't it? I hate this. I hate it. Never mind. Every time there is an error, I just have to paste this piece of code in. This is my solution. It's a shit solution, but it will work. Yeah, boys. Errors all over the place. That's it. This should be error free now. Cannot debug non-main package. Fine. That is map implemented in principle. Who knows if this has been implemented correctly. You know, the file close happens at the end of the function. That's absolutely fine. So I've only done the map. I can't even test it. Really. I'd like to do the reduce as well. I mean, it did something just now. That's because I have a bunch of prints, don't I? What just happened? What? It's printed a fuck ton of values that don't need to be printed. I think that's because I'm printing file names. I'm printing all sorts of shit, and I don't even know what I'm printing. That's not helpful for debugging. I'm printing the file, every file that is created. I'm printing that. I'm printing the inputs, and I'm printing. Yeah, this is not gonna. Forget this. This is just not gonna happen. So I'm printing the file names and I'm printing the inputs. So I think these are the inputs. The file name's probably all the way at the top. Yeah, let's not print the fucking inputs. I can't even get to the top. That's quite completely standard, and when you're iterating over lots of stuff in programming and you print it all, can it get to the top? Nah. Yeah, fuck that. So let's just delete that line. F&T println, no need to println there. Let's go. Mr. Wembley, it happened again. I don't know why it happened. What is this shit and why is it getting printed? Well, test 00 now looks like this. This is some, as you can see, correctly serialized JSON. But why the hell is it printing everything? Can you not? It seems to be, it seems to be working. Like, it has done what we wanted it to do, right? It's, I don't know what the test is exactly, but our end result is that we have, correctly formatted list of key values in JSON format. So these are, each line of these is a JSON with a key and a value, and they have all been printed to 0, 0, which I guess is the first test. Everything goes to 0, 0. So we only have 0, 0, one map task, one reduce task. This is a different test, I don't know what it is exactly. But yeah, whatever this test is, it is running 0 reduce tasks and just the one map task as well. I mean, it looks good to me. I don't know if it works or not yet, but we'll keep going until it works. And so next, there's no merge. The system cannot find the file specified. That's because DoReduce needs to make some files as well. So that's it. Next session we will do DoReduce, and we will basically crack out the next step, and then I think we'll be able to test everything once DoReduce is done. Part 1 will be done. It's going to be quite similar to what DoMap is. I'm going to do it the same way, read through the block of comments first and then just implement it like this. And yeah, basically, hopefully then we will, hopefully the test will be passed. We will find out if the test will be passed, and that's it. Yeah, nothing much to say anymore. I'm back at 9 today, 9 PM today, doing DoReduce. So, still MapReduce part, which is MapReduce is project 1 out of 4. So this entire distributed systems course is 4 projects. And this is part 1 out of 4, because the last one is optional and doesn't look that useful. We'll probably skip it first. So task 1, MapReduce, has 4 parts. This is part 1, implementing DoMap and DoReduce in the most basic sense. I've just done DoMap, I don't know if it's right. DoReduce in the next session. Hopefully it'll be fast enough that I can crack on to get it tested and then move on to number 2, which is part 2, which is implementing the pure functions for the word count, I believe. Sounds good to me. Let us commit to the Git repository. So this shit is telling me that a bunch of files have changed. I mean, I have these scrap files. What I'm going to do is just do a bit of file management. I'm going to make a scrap folder. I guess because this is a kind of educational project, I'm happy for the scrap folder to also be synced up by Git. So I think I'm happy with that. So yeah, if these go into the scrap folder, that's cool. Launch.json is a new file that may or may not come in handy when debugging. Probably isn't going to do shit, but fuck it. I'm not gonna git ignore anything. I'm gonna leave all the files in the repository. Common Go, that's what we edited yesterday. We just set it debug enable to true, and common map is the thing that we were working on today. So yeah, I'm going to say this is the end of stream 2. Do map. So yeah, project 1, part 1, let's call it 1.1, so use Super Mario Bros notation. Do map, done. Commit. Yeah, always commit everything if I don't manually choose what to commit, and yeah, that's it. So this is still not on GitHub. Should I put it on GitHub? Yeah, I think I will put it on GitHub. I'll do that later when I turn the stream off. So that's it. Okay, catch me at 9. Do reducing all the shit. All the shit's gonna be reduced. I need some fucking food, mate. I'm so hungry at this stage because I got up so late. So I definitely need to stop going to bed at like 4 a.m. It's just like pointlessness. I haven't even looked at at my stream much. I got another comment. Now again, I don't know when I got the comment. Twitch chat is just not. It didn't work. I mean, get a load of this shit. It just didn't work. Oh, it fucking expanded out and then I couldn't see it. Nightmare. Yeah, sad times. Do I have any way of finding out when this comment was sent? It will have popped up on the stream. It will have popped up on the stream, I guess, so if I flick through my video it will probably appear. But unfortunately I again did not see it. Never mind, guys. As I say, I'm just gonna drop the stream for now, come back at 9 PM and see if I can just deal with this comment situation. Like, I really wish I had a good way of reading comments as soon as they come in, because it's not like I get many of them. I can just like reply. Yeah. I'll figure out how to deal with that. Until next time. So, see you later, 9 PM.